understand how the value of g, that is accident to gravity, it changes with the depth, that is how we go deep down into the earth from the surface, how the value of g, accident to gravity, changes. For that, one major assumption is, that is the density of earth is constant throughout its volume. We know the inner core of the earth, it has molten lava and the density is huge. But once again, for the understanding of the basic concepts, we are assuming that is the density of earth is constant throughout its volume. Now, when the body is at the surface of earth, we are taking the mass of earth as m, radius is r, that is once again 6400 km. This is m. So the force of attraction between this point mass body and earth, the distance between the two centers is r. So we say gm upon r square, that is this force, is equal to weight of the body. We also understand that is mass upon volume is equal to density, denoted by Greek symbol rho. So from here we get gm upon r square is equal to g, and this mass we are taking it as a perfect sphere. The volume is, now mass is equal to volume into density, and the volume is 4 by 3 pi r cube into density. We are taking it as a density, so volume into density is mass, so m is equal to 4 by 3 pi r cube into rho. And over here we have r square, so this comes out with g, 4 by 3 pi r rho is equal to g. That is the accident to gravity at the surface of earth, where rho is the density of the earth. Now let's say we have gone d distance below this surface. When we have gone below, from here to here, and over here we are calling that is accident to gravity is g dash. Over here we are calling it g dash, and still our mass which we are taken over here is m only. The force of gravity which acts on this mass is only the sphere which is below this. That is because of this mass which we are calling it as m. This outer shell of thickness d will not be applying any force on this particle of mass m, because this outer shell is also composed of small particles, and this mass is being pulled in all the directions, and all the forces, some they are in the upward direction because of this shell, and some forces they are in the downward direction because of this shell mass. As a result, the net force because of this shell, outer shell of thickness d, they all get cancelled out. And to prove this thing, that is all the forces because of this shell, they will be cancelled out, Newton established a whole new branch of mathematics, that is calculus. So over here onto this mass m, the force which is being applied in the downward direction is only because of this mass, that is m dash, and it has a radius r minus d, because total is r, this is d, so remaining is r minus d. So m dash, if we talk about m dash, so once again the force between this and this is g m dash m upon r minus d square. That is once again we are using the formula gm m upon r square, where m is the mass of this, that is m dash, m is the particle which we are taken over here, r minus d is the distance between the two, that is this body and the particle over here, r minus d square is equal to m into g dash. G dash is accident to gravity at this point. So this once again we say m dash, so mass of this is once again volume into density, volume is 4 by 3 pi r cube, r is what, r minus d cube, into density, density we are taking it as constant throughout the volume, so whatsoever rho is over here, the same rho is over here, over r minus d square. So this comes out to be like this, we divide g dash by g, that is these two equations we divide, and we get g dash equal to g into 1 minus d upon r. So this is how the accident to gravity is changing with the depth. Over here when we say that is how the value of accident to gravity, the significant assumption is that the density of the earth throughout its volume is constant. And over here if you put d is equal to r, let's say g dash equal to g into 1 minus d upon r. If we take the depth as r only, that is radius of earth, so g dash equal to g into 1 minus r upon r, so this comes out to be equal to 0. That is accident to gravity is equal to 0. Rather at the SHM also we have done a question where we find out what is the time period of a body in a tunnel passing through its center, and over there we take its mean position, that is at the center the accident to gravity is 0. And if we have to compare, that is how, at what distance, what is the relationship between h and r, so that the accident to gravity is same. So for height we know the formula for the small heights, we have taken g dash equal to g into 1 minus 2h upon r, and over here we have said that is g dash is equal to g into 1 minus d upon r. If we say over here at this point a and at this depth d, that is these 2 points, one is at depth d and one is at a height h. Suppose we say that is over here is also g dash, over here is g dash. So what is the relationship between h and d? So it means this and this should be equal. So it means G into 1 minus 2h upon R should be equal to G into 1 minus D upon R. So this says 2h upon R is equal to D upon R. This implies 2h is equal to D. Or we can say that is h is equal to D by 2. And once again we can use this result only when h is very small as compared to R, because over here we have made use of binomial expansion, that is we have made use of approximations. So this result can only be used if h is very small as compared to radius of earth.